All right, good morning, eighth grade, period A. Hope you're doing well on this Monday morning, April 27th. Hey, by the way, April 27th, if you remember from a month ago, well, more than a month ago now, a month and a half, or almost 2 months ago, we calculated that the entire United States, according to that exponential model, luckily it turned linear, the entire United States would have coronavirus on this date. That's if the growth factor stayed at 1.34, I think it was. So, see, told you it wouldn't happen. We're all here, we're all alive, we're all good. So yeah. Anyways, let's try this here. So for today's next 2 days, I just want you to practice graphing these quadratics for an hour. So what do I mean by that? Do your own, less is more. So do whatever. Some of you guys will get through most of these. Some of you guys might get through like 4 of these or 6 of these. Just set your timer whenever you start for about an hour, and maybe do a half hour today and a half hour tomorrow. But just practice graphing for 1 hour. And you can subtract from that hour how long it takes you to watch this video. So I wanted to look at, I gave you 2 handouts to practice graphing on, but I wanted to look at this one here. And I wanted to graph, you don't have to do numbers 4 and 5. You can cross those off because we did those last week. I gave them to you as screenshots. So you don't have to do those. And now I want to do for you as examples numbers 3. And on the other page, I don't know where I have the other page here. Somewhere, number 3 and number 11. So I'm going to do those with a purpose because it's kind of going to be good examples on how to graph, and it'll kind of get us into our next section, which is graphing and finding solutions from our graph. So here we go. So let's look at number 3, another example of graphing. So number 3, we're going to graph x squared plus 8x plus 12. Okay, so if this was a quadratic equation, I'm going to go off to the side here for a second just to prove a point. If we go back to chapter 9, if this was a quadratic equation, we would write this as x squared plus 8x plus 12 equals 0, correct? So we could then factor this, okay, to get our solutions. So this is factoring to get solutions, and then we're going to graph it and see what we can kind of see how they're both very much related. So if we factor this, we would go x parentheses, okay, our a value is 1 equals 0. We think about things that multiply to be 12 to add up to 8. So I'm thinking, I don't know, 6 times 2. So like plus 6 plus 2, right? I think that works, right? X squared, inners is 8x, outers is 2x. That gives, yep, it all works. So then you'd write x plus 6 equals 0, x plus 2 equals 0. So your solutions would be x equals -6 and x equals -2. Okay, that's if we were doing it by factoring. Then we introduced quadratics in the sense of graphing them. Okay, so we'll go through graphing it and then see if there's some type of comparison or something we can discover from this. So if you graph this, right, we start off with our x and we get -b over 2a. So x is going to be, and I suggest when you're graphing all of these, if you still have your handy dandy book from before, factoring quadratics book, or any just line paper, I suggest you do all your tables and figuring on line paper or in that book, and then go and graph. So here goes. So now I'm going to do my work here, and I'm going to put -b, which is -8, 2 times 1. So this is -8 over 2. So I now know that I have a line of symmetry at x equals -4. Okay. So I'm going to keep going from here to my graph a bunch of times. I need to get, so I'll just go -4 This is number 3, 1, 2, 3. Okay, bam. My line of symmetry is there. Okay, I need to get my y value so I know my vertex. So I'm going to plug in x equals -4 in there. So -4 squared plus 8 times -4 plus 12. This is going to be 16 minus 32 plus 12. And let me just grab my calculator to figure that out. Yeah, it's -4. That's what I thought. So my coordinate now for my vertex is -4, -4. So now I'll go over here. So I'll put a dot at -4, -4. I know it's facing up because that's +1. So now I'm going to make a table. I'll get a couple of points here. So I will try, I'm going to go not too far. I'm just going to go out to like, I'll go to, I want to keep the numbers easy. So I'll go to -2. Okay. So if I go to -2, x equals -2. So I get y equals -2 squared plus 8 times -2. Yikes, my bad. Plus 12. So I get -2 squared is 4 minus 16 plus 12. If you look at that, that's going to be -12 plus 12, y equals 0. So now in my table here, so I'll have off to the side a table going. I have x, y. The first coordinate I got, of course, was the vertex, -4, -4. Then I just got -2, y equals 0. So when I go to graph that, -2, y equals 0, it's right here. Now to get the other side of my parabola, 1, 2, 1, 2, right there. Interesting. Hopefully you're seeing something. Maybe you haven't seen it yet, but let me do one more. If I wanted to do my y-intercept, which I sometimes like to do, of 12, you can see it doesn't go that far up. Let's see. I don't even know if -3 will go that far up. So let's see what happens when I put in -3. So I go y equals -3 squared plus 8 times -3 plus 12. I'm just going to go here to my calculator, do a little of that here. So that's going to be, let's see, I'll roll it like this. So that's going to be 9 minus 24 plus 12. -3. All right, I can graph that. Y equals -3. So I just got -3, -3. -3, -3. Yeah, that works. So -3, -3. So I'm going to come here. Oops, I probably should have done -1. -3, -3. Right here, right? Yeah, I should have done that -1. And then over my line, so that's -5, -3, -5, -3. Let me do that -1 now, finally. My bad. I'll throw a -1 there too. Here, sorry. And you can see this takes a little bit of time, so especially to get all the right coordinates, depending how many. If you can get some of these graphs, you can get like 5 coordinates. Some of them you might only get 3 if they're really skinny and they don't fit too much. So now I'll do y equals -1 squared plus 8 times -1 plus 12. So that's 1 minus 8 plus 12. That's -7 plus 12. Don't want to make any mistakes. That gets y equals 5. So then you come over here, you're like, all right, 5. Then you're over here, you're like -1, 5, which is here. 1, 2, 3, 1, 2, 3 here. So now I got my parabola, right? So there's a point I'm trying to make by this. I'll get there here. Okay? So you look at the graph and compare it to what we did with factoring. So this is the graph, and this was our factoring to get the solutions, right? So look at the solutions when we factored. It was -6 and -2. Now look at the graph. Do you see -2 and -6 anywhere in our graph? Hopefully you do. It's right here. It's right here. So basically, the moral of the story is your x-intercepts. I'm going to write that down here. Your x-intercepts of parabola are your solutions. All right. So that's cool. That's a great discovery there. So to see it a little bit better, right? I had it set up in Desmos here. Where's my Desmos? Yeah, right here. Boom. So then I go here, here, and I now highlight it. See, there are my solutions here. -2 and -6. Those are my solutions to this parabola. Now you might say, Mr. Patello, what if my parabola doesn't hit the x-axis? Well, if that doesn't happen, and you don't have any x-intercepts, guess what? You have no solutions. You would never be able to factor that. It just wouldn't work. So let me see if I can make that happen quick. I'm gonna throw a 4 here. Whoa, where the heck that thing go? Can't even see it. Whoa, yeah, that right there, no solutions. It never crosses the x-intercept, the x-axis. So that's pretty cool. Let me see if I can, I don't know, I can keep playing with it, but I'll be here all day. So again, good stuff there if you're able to follow. So I'm going to do the same thing. I'm going to do another graphing question for you. Half your graphing time is going to be just spent watching this video. It's all good. Like I said before in the past, our lessons are going to stretch out pretty long now that we're just spending a half hour on math a day. So let's do this next one here. This is number 11, right? So I'm going to go here, number 11. Here. Okay, so we're gonna graph this. We can do it. Okay, don't get freaked out by the fractions. Try not to freak out. Let's, before we do it, let's do it by factoring. Okay, factor. Okay, this was the other chapter. We go -1/2 x squared minus 4x minus 6 equals 0. Now, if I look for common factors, technically, couldn't I factor out a -1/2? Of course you could. And then if you factor that out, you're left with x squared. Half goes into -4 positive 8 times, and a half goes into -6 positive 12 times. Do you see the similarities there? It is exactly what we had for that last example. So I already know my factoring. I'll just write it because it's there already. X plus 2 equals 0. I already know solutions to my graph here are going to be at -6 and -2, just like the other one. But is my parabola going to look the same? No, because my a value is negative. It's going to be facing down. My a value is a fraction. It's going to be pretty wide. So let's do that now. Okay. So number 11. Boy, what time is it here? Oh boy, it's 10 o'clock. I still have to post for the other classes and post this video with your work. So here goes nothing. Half of you guys are probably just still sleeping anyways, but I like to try to get it out by 10. So anyways, my bad. So let's go x equals -b over 2a. That is not a -b, that's a -2. So we're going to get 4. -4 is positive 4 times 2 times -1 half, right? So that's going to be 4 over -1. So x is -4. So I have same thing as last time. Again, I knew these are very similar, so that's why I chose them. So if I go number 11, -4, line of symmetry. All right, so now let's do this here. Let's get my y value. So I go y equals -1/2 4 squared minus 4, -4 times -4, sorry, -4 minus 6. So that's going to be 16 positive, but times a -1/2 would be -8 plus 16 minus 6. So this is going to be y equals, okay, so my vertex is going to be different here. Let me just double check this here. So -8 plus 16 minus 6. Yeah, it's going to be +2. Okay, so my table, as I get it going here, I have my vertex, this is my x, my y. I have a vertex at -4, 2. Okay, so I'm going to go here, -4, 2, put my vertex. Now I know it's facing down. Okay, spoiler alert, don't forget what the solutions are. Okay, so now let me throw in, yeah, I might have, this one I can fit my y-intercept. So remember when we were talking last week during the Hangouts, my y-intercept is not my a, not my b, but my c value. So I know that when x is equal to 0, I'm going to have an intercept at y is equal to -6. I always get, yeah, let's make sure I get that. So here, and then I'm going to go here. 1, 2, 3, 4, 5, 6. Put a dot. How many over to my line? 1, 2, 3, 4. 1, 2, 3, 4. -8, -6. Put that in my table. -8, -6. Okay. Let's throw in -1 just for the heck of it. So when x equals -1, let's see what y equals. So I get y equals -1/2 times -1 squared minus 4 times -1 minus 6. Sorry, that comes out to -1/2. Right? Ew, that's not gonna be good. Plus 4 minus 6. Right? So that's going to be 4 minus 6, isn't that -2? So -2.5. Disgusting. -2.5. All right, so -1. Ew. -2.5. 1, 2, 3. 1, 2, 3. That's -7, -2.5. -7, -2.5. And then the last one, this is the one that was supposed to be the grand reveal. What happens when you put in x equals -2? So you get y equals -1/2, -2 squared, minus 4x, minus 6. This is 4 times -2. All right. I keep doing that. It's -2. That's a 4. Hopefully you can see that. It's a 4. So you get negative. That's 4. 4 times -1/2 is -2. This is going to be +8 minus 6. Y equals 0. Uh-oh, we got a solution. So we got -2, 0. So now we go here, -2, 0. There's a solution. 1, 2, 1, 2. There's the other solution. So it's -6, 0. -6, 0. Okay. So again, these are my solutions. My x-intercepts, remember back in the beginning of the year, are when y is equal to 0. My x-intercepts, those are my solutions. When I factored it, it was the same thing. Okay. Connect my dots to make my smooth curve. It's a wider parabola facing down, like so. Okay. So now, just for a heads up, as you're doing this handout, the only other ones that are going to have solutions that work like this is numbers 2 and 3. The rest of your parabolas are not going to have x-intercepts. And now that I've just realized how much I just talked through this video, I think I was going to assign another handout to go along with this, but I think with the fact that I just talked and taught almost like 20 minutes, I don't even know what I'm at. But yeah, why don't we just do one handout today? Because it has 18 questions minus the 2 we did, minus the 2 we did last week. That's 14 questions. You have answers to the first page, not the second page. You know that 2 and 3 are going to have solutions. So yeah, let's cut it down a little bit, because just by watching this video and learning with me, that should take up a long time. So anyways, going back to that graph here, so this was number 11, right? If I go back to my Desmos that I had set up in my background, right here, there's that function. and then here we go here. Okay, so you can see it's got a solution, same thing, right? It's got the solution at -6, -2. Let me grab my book really quick. I just want to prove to you that this works, right? If I go back to anywhere in chapter 9, when we were doing all these wonderful quadratics and we were solving and being awesome and solving quadratics before this all happened, right? Let me throw in one that looks like it would work. Sorry, almost done. Okay. Wait for it, wait for it, wait for it, wait for it. Okay, yeah, so if I just, this is one of the problems where you would learn how to factor before, okay? So it was negative 4x squared plus 12x plus 7, okay? So when we factored this and we did our, normal factoring routine, y equals, I think with this one you'd factor out the -12. I'm sorry, the -4. Factor out the -4. Look at the solutions here. If I unhighlight these and just look at the green, okay, I would have solutions at here, -1/2 and 3.5. Yeah, and then I'll show you this in the book. Sorry, I thought that would be a little bit more even. I just randomly went to my page. If I went to my book to show this to you, I think the factorization, probably should have picked a better example. Here was, there it is. If you make that equal to 0, 1/2. If you make that equal to 0, sorry, -1, yeah, 1/2. If you make that equal to 0, it would be 3/2. Okay, so again, that was that quadratic from chapter 9. So I hope this video helps you get started. Again, I'm just going to share with you one handout with those questions. So good luck.